This is the first out of 3 videos on sketching transformations given the graph of the original function. In this video, we will sketch the following easy examples. Example 1, f of x plus 3 minus 2. This has 2 transformations. The minus 2 means that there is a vertical shift down 2 units.
And
The plus 3 inside the parentheses, however, means that there is a horizontal shift to the left 3 units. I know, plus 3 looks like a shift to the right, but horizontal transformations are counterintuitive. Here is the graph of f of x. I've marked some of the points on the original graph. In order to graph the transformations, we will move each point one by one, starting with this point down 2 units and left 3 units. This point also moves down 2 and left 3. Do the same for all the points and you will have drawn the transformed graph.
This point is over here, okay? This point down, 1, 2, 3. So this point is over here. And finally this point goes down, 1, 2, 3, here. Alright, that's it.
Example 2, negative f of x. This graph only has one transformation, a reflection over the x-axis.
Over, yes, this.
Let me demonstrate how each point is transformed.
This point down.
This point down here is 6 units below the x-axis, so its reflection will be 6 units above the x-axis.
This moves over here.
Next, this point is on the x-axis, and so its reflection will still be on the x-axis. This point is about half a unit above the x-axis.
Will be.
Thus, its reflection will be half a unit below the x-axis.
Are you getting it? This point stays on the x-axis. Now this point was below, so it should reflect over. This point stays, and this last point reflects below. There.
When you reflect over the x-axis, we only change each point's vertical location. Their horizontal location stays the same.
Horizontal location stays the same. Same horizontal location. Okay. So that's example 2.
Example 3, f of negative x. This graph also only has one transformation, a reflection over the y-axis. Let's transform the points one by one. This point was 2 units to the left of the y-axis, and so its reflection will be 2 units to the right of the y-axis.
To the right on the y-axis. Okay, so it goes like that. This point reflects here. So we can start connecting. Okay, this point goes here. This point stays there. This point moves here. And this point moves there. And finally, this point flips, right? It goes and goes there. Okay.
Example 4,
Negative.
negative f of negative x. Let's use a different given graph for this demonstration.
Yes.
This example has 2 transformations,
And this one.
a reflection over the x-axis and a reflection over the y-axis.
So
This first point was 8 units above the x-axis,
units.
so its vertical reflection will be 8 units below.
Okay. This is going to be here.
Since it is on the y-axis, its horizontal reflection is itself.
Is itself. Since it is on the y-axis. Okay. Next, this point reflects over the x-axis and then over the y-axis. Get it? So that's this point is itself. So this is itself. Then we reflect over the y-axis. Get it? This point reflects up and then reflects left. This point stays and then reflects here. This point reflects down and then reflects here. And finally this point reflects down and there.
Example 5. Negative f of negative x minus 1. There are three transformations. A reflection over the x-axis, a reflection over the y-axis, and then a shift down by 1 unit. This means that you simply need to repeat the steps in example 4, but also shift all the points down by 1 unit. This is the perfect time to mention that you must do all the reflections first before you do any vertical or horizontal shifts.
This moves there and then down 1 unit. So it's down. This reflects up, reflects there, and moves down. This stays there, reflects here, goes down 1 unit. This reflects there, reflects there, then it goes down 1 unit. And this reflects here, reflects here, and goes down 1 unit.
Example 6 is for you to try on your own. You can check your work on Desmos by typing these functions. I hope to see you in the next video for intermediate level examples.